We have, I think, uh, we got some understanding that what is multi-label. So next, the techniques for solving multi-label classification problem. If you have a problem of multi-label, then how you gonna deal with those that scenario? As I told you, there are three, and the one is problem transformation. Means you need to transform it into from multi-label to multi-classification and then apply a standard classifiers. And another one is that adapted algorithm. The normal algorithm will not be sufficient, and you don't want to transform uh, the multi-level into multi-classification. You just want to change your algorithm, you and then apply that algorithm to multi-label classes. Let me get in this guy. Okay, so oh, people are keep joining us. Just to recapture everything back. Okay, so today our lecture is about multi-level classification, and in this lecture we will identify that what is multi-level classification actually, and what is the difference between multi-classification and multi-level classification, and then loading and generating multi-level data sets, and what are the techniques solving multi-level classification. There are three techniques: problem transformation, adapted algorithm, and ensemble approach. um, like this image belongs to multi-level classification. We can label this image to, this is not only the image for houses. This image is not only for tree. So this image classify to more than one classes like houses, trees, skies. And here you can see we have three classes. We have three classes: sun, moon, and cloud. So we can say we have multi-class, we have multi-label, we have multi-classes. So this image belong to which class this image belongs to cloud. And to other classes, the probability to belong is 0. So it says 0 for sun, 0 for moon, and 1 for cloud. And this one, the first one is for sun, and the second is moon 0 and cloud 0. This means this image is a sun. It is not a moon, and neither it is a cloud. And similarly is like this. So every image belong to one of the class from out of multi-classification. But in this case, one image belongs to more than one classes. You can see uh, an image belongs to all the classes, and here an image belong to two classes, and we have an image that belongs to single class. So that is this is an example of multi-label. Okay. Here is we can see binary classification, the application of binary classification. We can have like an email. The email could be spam or not spam. There are two scenarios, two classes. That is called, and that scenario is called binary classification. Here we can see we have multiple classification like dog, cat, horse, fish, bird. So we have five classes, multiple classes, and the dog belong to one out of those five. But in on the far right side, we have an image, and that image belongs to more than two classes. Like this image also belong to cat, and this image also belong to bird. So one image belong to more than two classes. That is an example of multi-level classification. So when we have such a situation and you want to solve them, there are three methods. Number one, problem transformation. Problem transformation, as I told you earlier, that transforming the multi-label scenario into multi-class and then apply regular classifier machine learning algorithms. And another one is do not change or transform your scenario. You should change your algorithms. Do not use regular algorithms. You just made some changes on it, and we have already built in algorithms, different algorithms, some change algorithms, and that is known as adapted algorithms. And we can use them to uh, to sort out multi-level classification problem. Ensemble approach means you can apply more than one machine learning models, m- more than one machine learning classifier uh, to sort out, to solve the multi-level classification problem. So in problem transformation, we have three categories: binary relevance, classifier chains, and label part set. Okay, so let's move and see what are these three uh, types of problem transformation. So for example, this is the simplest technique, which is basically treat each label as a separate single class classification problem. For example, let us consider a case as shown below. So this is a case, for example, this one. We have input, and these are the classes, four classes. Okay, so look, X belongs to Y2 and Y3 at the same time. And X2 belong to single class that is known, that is, we can see is Y1. And X3 belongs to Y2. X4 belongs to Y4. And X5 belongs to Y4. So this is an example, and we want to solve this by boundary relevance. So this problem is broken into four different single classes classification problem as shown in the figure. So you can see we have we made it like four classes. One is this, another one X with Y2, X with Y3, and X with Y4. So now you can see this becomes multi-label classification, multi-classification. Everyone is a multi-classification. So now apply, so these are the data sets. So apply the model on this, and then on this, and then on this, and then on this, and then find and train model on it, and then you apply your, you get an input and try find the appropriate class. So how we can do that? You will have data set in this form. You will have data set in this form. You can break them into like this: X data set and Y is the Y1 is the label. X is the input, Y2 is the label. X is the input, Y3 is the label. X is the input and Y4 is the label. So we have four data sets and train the model on these, and then you can use it. So this is called binary relevance. Here, okay, in this, the first classifier is trained just on the input data. So we will have input data, we will train our input data on it, and each next classifier is trained on the input space and all the previous classifiers in the chains like this. We have, this is our scenario, multi-label scenario. So you can see we have input. This is our input. And these are the classes. So this x1 belongs to two classes at the same time, y2 and y3. Like a movie could be comedy, and at the same time it could be a science fiction as well. So if you have this scenario, we are dealing with transformation method. Okay, so what you can do, take this as input, and this is your label. Train your model on this, and then you, whatever output is come, this would becomes your input, and the next will be your label, and then combine this as an input, and this will become your output, mean target one, and take this as input space, and this would be your label. So this is called classifier chain. So what you are going to do here, you are dealing with data set. You are not dealing or changing your classifier or model. You are just dealing with the data sets and making, like this one is a multi-label classification scenario, and you are transforming it into multi-class scenario. Once it is transformed into multi-class, you can apply your regular models. And at the end we will do some experiment as well. Label power set. So what is this? Again, we have input data, we have data set. Here we have input data, and this data belongs to these, some of the classes, or all of the classes, or none. So you just try to find out the similar rows. For example, look at this rows, x1 and x4. Aren't they same? X1 and x4 are same. You can see whatever x1 has in label, the same x4 has the label as well. So x1 and x4 are from the same label. So uh, we will assign them code. For example, I'm assigning this to 1, 2, 3, and this is also the same like 1. So I'm going to make it 1. And this one is also similar to, no, it's not similar to anyone. So this would be 4. And how about this? This is similar to 3. So your classes now becomes 1, 2, 3, and 4. So your multi-label classification transform into multi-classification. So now you can apply your regular model like ICM or random forest or decision tree or whatever suits to this model. So How we tackle with multi-label classification? We tackle by dealing, by processing, by converting the data set into multi-classification form. So that is called transformation uh, method. And here is an example of we will go later uh, by executing it. So what was, let's see that we have libraries. We included some libraries, and we have a Gaussian classifier. We got some data, and we predict, and we got this one. It's an accuracy. Okay, so here is multi-level classifier. Okay, we will execute this later. So let's come to this adaptation algorithm, adopted algorithm. So in adopted algorithm, we will not change our data set. We will we will use an algorithm, a regular algorithm, we familiar, and we will use a changed version. Like we know k nearest neighbors. So there is another advanced KNN algorithm for multi-label classification that is known as MLKNN. So we will use this. So this is called adapted algorithm. So how it deals, like for example, we have classifier MKLN. We are using 20 neighbors. This is the classifier. We got data set, and that is a multi-label data set. We apply our classifier, and then we got some prediction. When we apply X data set, test data set, and then we find the score, and we have 0.88. So scikit-learn provides inbuilt support of multi-label classification. So scikit is the Python library, and it has built-in multi-label classifier, so we can use them. And the MLKNN is one of them. This one is one of the classifier for multi-label classification. But we have random forest, we have ridge regression as well. Uh, a different version of those. Here, just explain it MLKNN. While ensemble approaches, you already know that ensemble means more than one classifier when you use. So you can use more than one classifier if you don't like these two approaches. All right. So what is it? So here we have a case study. We have a restaurant reviews data from Twitter. So the authors of the text may mention some aspects. We just divided 5 aspects, like 5 aspects means 5 classes: service, food, anecdotes means stories, price, ambience. Ambience means the look and feel. If you go into the restaurant and you feel like good, so so ambience means those things. So we have data in CSV model, and the data was extracted from uh, online, from international work group on semantic evaluation. So this group generated that data, and we have it in CSV file. And in CSV file, data is in rows and columns. So each row is formed by the text. So each row contains text, and the aspects contained on it. In the presence or absence of those aspects is represented by 1 and 0 respectively. Means we have text, and there are the 5 aspects, or you can say classes. For example, the first one says, but the staff was so horrible to us. So here, uh, the the essence of the text is about service. So we turn service bit on. We have 1, and it is not talking about food, so this is 0. And it's not about telling a story, it's 0. There is nothing about price, 0, and there is nothing about ambience. So the service, so this is about a service. People are keep joining the class, so I have to repeatedly go in and letting them in. Another look at another text. To be completely fair, the only redeeming factor. Okay, and there is 3 dots, means the sentence is not completed. There would be something else as well. So in the data set we have 1 at food and 1 at anecdotes, and the rest are 0. So means this sentence belong to food and this sentence belong to anecdotes. So this sentence belong to 2 classes. So we have CSV data like this. And now we have to apply some algorithms on it. So first we imported libraries, PD, NP, and these are the standard libraries. And here we are using this one. This is for multi-label classification. So what we are going to do, import the text and split them properly to train the model. So we imported the data and then split the data into 2, train and text. The raw text itself doesn't make a lot of sense to machine learning algorithms. There are many different forms to represent text. So it is basically belong to text mining. So what the raw text doesn't make some sense. So we are extracting TF-IDF, which stands for term frequency and inverse documents frequency. So it is used to represent the importance of each word inside a text corpus. And next, assign the set of text to X. Means all the text like this. We assign this is X, and all others we will assign to labels. To convert data from raw text to TF-IDF, an instance of the class, so we know that we can convert this by TF-IDF vectorize, and then we will use fit to train the model, and after that we will train on 70% and test on 30%. So this is the code. Here you can see we are reading CSV file, and here we got aspects into X and the label into Y. We are vectorizing, like we are making a vector of TF-IDF here, and we train them. We split that, and then we train them, and after that we transform the data into multi-classification, and then we got some results. Like once we trained them with MLKNN, we give them a sentence, and then the algorithm will predict and will say 01001 means there is this sentence doesn't belong to service, this sentence belong to food, and this sentence doesn't belong to anecdotes, and neither it is belonging to price, and it belongs to ambience. So this sentence belongs to two classes. Number one, food. I like the food, but I hate the place. And it means uh, it belongs to number one, food class and the ambience. All right, so now the next important thing in multi-label classification is how to measure the accuracy. We cannot use the regular accuracy technique. Why? I'm going to explain it here. For example, you have five, 1, 2, 3, 4, 1, 2, 3, 4, and 5 instances, and this text belongs to a class service, and this text belongs to two classes, and this one, so this is true labels, and that is our predicted one. Our model predicted about these, and we have this one. So how we can compare both? How can we see that how much our model is accurate? If we use the traditional one, then we have five classes, 1, 2, 3, 4, and 5. This is actually 5, not 4. So we have five classes. Look at this, 1, 2, 3, 4, and 5. Here, five classes, 1, 2, 3, 4, and 5. So which one is true? The actual value is 10000, but it's the prediction is says no, it is 01000. So this is the wrong prediction. And here this one is also wrong. The only correct is this one. Look, services 1, food, anecdotes, price, and ambience are all 0, and it says food and anecdotes, price, and ambience are all zeros. This is the only one we have corrected one if we use the standard accuracy techniques. So in that case, the accuracy is 1/4, means 0.25. This is not a correct method of the accuracy for multi-label classification. This is for multi-classification. This accuracy is for multi-classification, not for multi-label. So we have another one, the Hamming methods, known as Hamming methods, Hamming laws actually. How it does things, I'm going to explain it here. So how many predictions are here? How many predictions? The total in this table, including this, how many prediction is in actual table? Each instance is a prediction. So 1, 2, 3, 4, 5. And how many columns? 1, 2, 3, 4, and 5. So there are 25 predictions, actually, 25 predictions. And this is the predicted values. So let's see that how many times it was correct. So let's see. Look here, it says 0, while actually it was 1. So this is wrong. The actual is 0 and the predictor is 1. So that is also wrong. But these three, 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Hold on. Let me see. 1, 2, 3, 4, 5, 6, 7, 8. All right. So total. So this is correct. This one is correct. This one is correct. This is the correct one. This is the correct one. So the dark color are incorrect. So total number of incorrect are 8, and the total predictions are 25. So 8/25 is 0.32. So Hamming laws shows that the accuracy of our model is 32%. So when you are using multi-label classification, you have to use Hamming laws for accuracy, not the standard one. So in Python, you have built-in Hamming loss method, so you don't need to worry about to to write your own code. So let's move to our Anaconda. Okay, so if what is it about? Yeah, this is the CSV class as a CSV, the data, and this is about the restaurant review and Twitter data set. So you can see here we have text, and these are the classes. So here you are taking these values into X. Okay, so let's check it first. Let me print that what is in X. So here you can see X contains only the text values, while the Y contains all the other labels, multi-labels. Let's check this as well. So you can see 100, 011. So these are the values. Here you are doing tokenizations, uh, TF IDF, and then you are going to split the data. So you have the data in here, and now you want to uh, let me print that just to see. These are X values, and now split that into train and test. So you have X train data and Y train the labels, X test and Y test. If you want to see that what is in Y train just hold uh, labels for the training values. X train and Y train we are going to vectorize, transforming it into vectors. Okay, and then you get an object or handle of the MLKNN multi-label classification, k nearest neighbors, and using default neighbors. Okay, so you have trained your model on the X train, TF, IDF, and Y train, and now you are going to put a sample test value, and we'll see that to which that belongs to. Let me. I like the food, but I hate the place. Look at this. So that it shows that it belongs to class second and the last one. Let me I let me check that. I Oh, come on. I like the food, hate the service. See, you see, this belongs to three classes. First service, and then about food, and then the ambience one. Ambience means I hate. All right, this it says that this only belong to the second one, food. And now we are going to make an accuracy. So this shows that the accuracy is 0.472 and the Hamming loss is 0.16. So guys, we there is another example. Let's just to see that what is it about. Okay, so yeah, we have some attributes 1, 2, 3, 4, 5, and then we have classes, um, 5, class 6, class 7, class 8, 9, and 14. Let me see, what is it? Oh, yes, we have that. Let me check that. We have this data, and these are the train values, and from here. Okay, so we have a data, and that data I just got from internet. I downloaded this yeast train, but I'm forgetting what was that the data about. So we have the data. We we got x values and the y values. Y is about the label. If you just put it here and print it out, so these are the labels. How much? One, 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 one. Oh, okay. I don't know how many data is there, but we have data in x, and y is the label, and then we split them into two, and after that we are using binary relevance. Okay, so binary relevance. What is binary relevance? This was the binary relevance. If you have input data here, like if you have input data, with the pen. Sorry. If you have the input and four classes, you just split it into four. So x and y1. So x is the input data, y1 is the classes. And another is x the input and y2 is the classes. So you just divide it into four, and it becomes no multi-classification problem from multi-label. And this is called binary relevance. So here we are using binary relevance one. We are applying binary relevance techniques. When you use binary relevance, you got accuracy of 0.76. And if you want to use chain classifier is this one. Yeah. So this is the data, and we have multiple classes. You divide it into four data set. First, x is the input and y1 is the label, and then add y1 as your input data, and y2 becomes the label, and then you just adding the input space uh, in every step, and adding new labels like in this fashion, in this pattern. So classifier chain, you just import skm multi-learn problem transform import classifier chain, and then naive Bayes classifier you are using for this. If you run that, you got accuracy 0.24. In the previous, you got accuracy 0.76. So it seems we are the accuracy is degraded. But if you use label power set, the accuracy comes 72%. How about if we use adapted algorithm like apply MLKNN on the same dataset? You will get the same class, same accuracy, 0.72. Okay, yeah. Okay, guys. So this was our last topic in your class. But I hope this is surely this is not the end of machine learning course. But I'm hoping that you guys learn some tools that will be useful to explore by yourself and enhance your skills in machine learning. So in the next class, we will discuss we will discuss topics in examination point of view. So in the meantime, if you have any questions, you can pass your queries via WhatsApp, or you may call you may make a call on office timing. Then we will discuss this. So I'm ending that session, uh, and this is done from my side. Okay, guys, thank you.